A shockwave, traveling at 1,293 kilometers per second, just left the sun, and NOAA's modeling now shows part of the coronal mass ejection driving it is heading for Earth. The arrival window opens late Saturday into Sunday. This came from a single sunspot region that fired 2 X-class solar flares in 8 hours, one of the most active configurations of solar cycle 25 so far. Here's exactly what's been detected, what NOAA is forecasting for the weekend, and why the sun isn't done yet. Stick around for this one, it matters more than you think. Let's get into it. At 8:13 Universal Time this morning, the sun fired an X2.5 class solar flare from a sunspot region called 4419. It was the second X-class flare from that exact region in just over 7 hours. The first one, an X2.4, peaked at 7 minutes past 1 o'clock Universal Time. By the time the second one peaked, the National Oceanic and Atmospheric Administration was already tracking the first coronal mass ejection. And by the end of the morning, the Space Weather Prediction Center had a formal alert on the table for a Type 2 radio sweep moving at roughly 1,293 kilometers per second, about 2.89 million miles per hour. Both flares produced an R3 strong radio blackout on the daylit side of Earth. Both were accompanied by unusual radio signatures, a Type 4 emission starting at 8:40 Universal Time, and a 10-centimeter radio burst that peaked at 570 solar flux units. For context, the daily background at Penticton right now is 128, so that burst was roughly 4.5 times the normal level. It was, in every sense of the word, loud. But that's not the reason this story matters. The reason it matters is the coronal mass ejection, because the Space Weather Prediction Center has now flagged an Earth-directed component for at least one of today's eruptions. And the arrival window opens late Saturday into Sunday. Let me explain what we know, and then I'll tell you what that actually means for the next 48 hours. When a coronal mass ejection leaves the sun fast enough, it pushes a shock wave through the solar corona. That shock wave gets picked up by ground-based radio telescopes as a specific signature, a Type 2 radio sweep. And the frequency of that sweep lets you calculate how fast the CME is moving. The Space Weather Prediction Center's first alert, issued at 57 minutes past 8 this morning, reported an estimated shock velocity of 1,869 kilometers per second. That was serial number 1477. About half an hour later, at 27 minutes past 9, SWPC canceled that alert and reissued it at 1,293 kilometers per second. That was serial number 1479. I want to be direct about that correction. It wasn't a cover-up. It was a forecast office tightening its estimate as better data came in. Real-time space weather has inherent uncertainty in it, and reissuing an alert with a revised number is exactly what a responsible forecast office does. Both values, by the way, are in the fast CME range. Here's the context. The most widely cited database of coronagraph CME observations, built from the LASCO instrument on the SOHO spacecraft, gives a median CME speed of roughly 400 kilometers per second. The mean is a little higher, dragged upward by a long tail of fast events. The top 1% sit above 2,000 kilometers per second. Today's shock, at 1,293 kilometers per second, sits above the 90th percentile of all observed CMEs in the satellite era. That is fast. It is not a Carrington event. It is not the strongest thing the sun has ever thrown at us. But it is the kind of number that makes forecasters pay close attention. When the X2.4 erupted early this morning, the first coronagraph images suggested the coronal mass ejection was heading off to the northwest, off to the side of the Sun-Earth line. That would normally mean a glancing impact at worst, or nothing at all. But subsequent modeling by the Space Weather Prediction Center flagged something different. The ejecta envelope is wide enough that an Earth-directed component is now on the table with an arrival window opening late on Saturday, April 25th, and running into the early hours of Sunday, April 26th. That's the first CME. The second X flare, the X2.5 at 8:13 this morning, is still being modeled at the time of this recording. We don't yet have a final trajectory call on that one. But with a Type 2 shock speed of 1,293 kilometers per second, it's moving fast enough to matter. And here's where it gets interesting. Yesterday, April 23rd, an M1.2 flare from a different region, region 4420, also launched a coronal mass ejection. That earlier CME is expected to produce a glancing blow on Earth on Sunday, April 26th. It's slower, it left earlier. But now, today's X-flare CMEs are heading for the same patch of space, a little behind, possibly moving faster. If they catch up to the slower CME, they merge. That's a real thing. It's called CME cannibalization. A faster eruption overtakes a slower one en route to Earth, and the two merge into a single, more complex, more compressed magnetic cloud. The upstream solar wind gets compressed too, pushing the arriving plasma into a configuration that can hit Earth's magnetic field harder than either CME would have hit individually. The reference case for how this works is the May 2024 Gannon storm. That event was a multi-CME setup where cannibalization elevated what would have been a moderate geomagnetic event into a G5 extreme, one of the strongest storms of solar cycle 25 so far. Aurora was visible as far south as Florida. Power grid operators logged voltage fluctuations across multiple continents. Precision GPS was degraded for hours. A number of low Earth orbit satellite operators had to execute collision avoidance maneuvers because the thermosphere density changed faster than their orbital models could track. I'm not telling you today's event will rise to Gannon level. The Gannon storm was a direct hit event involving a sun-facing active region at disk center. Today's X-flares came from near the west limb. The geometry is different and less favorable for a direct hit. I'm telling you the physical setup. Multiple CMEs traveling through the same region of interplanetary space, with a faster driver potentially catching a slower predecessor, is consistent with a minor to moderate storm that carries some upside risk. And the Space Weather Prediction Center's forecast reflects that ambiguity. They are forecasting G1 conditions with G2 moderate explicitly kept on the table. The formal Space Weather Prediction Center forecast for the next 72 hours calls for isolated G1 minor to G2 moderate geomagnetic storming conditions late on Saturday into early Sunday. The peak expected KP is 4.67 during the 15 to 18 Universal Time window on Sunday, April 26th. That's 11 a.m. to 2 p.m. Eastern Time. Let me translate that. The G scale runs from G1 minor through G5 extreme. G1 corresponds to a KP index of 5. G5 corresponds to a KP of 9. A peak KP of 4.67 sits just below the G1 threshold. But SWPC has explicitly flagged that G1 conditions are possible during that window, and G2 moderate cannot be ruled out if cannibalization amplifies the arrival. What does that look like on Earth? Aurora, visible at middle and high latitudes if skies are clear. In the United States, that could mean aurora photography opportunities as far south as the northern plains, the upper Midwest, and northern New England for a G1 event, and further south for a G2. Some high-frequency radio issues on transpolar and high-latitude routes, minor GPS accuracy degradation for precision users, surveyors, geophysicists, precision agriculture, minor voltage fluctuations on long-line power systems, nothing the grid can't manage. This is not a Carrington event. This is not a Gannon-level storm. This is a minor to moderate event with some upside risk from the cannibalization setup. On the radiation side, SWPC is forecasting a 25% probability of an S1 minor solar radiation storm both today and tomorrow. That's driven by the flare activity of region 4419 as it rotates toward the west limb, and by region 4420 as it approaches central solar meridian. On the blackout side, R1 and R2 radio blackouts are essentially expected. 75% probability every day through Sunday. R3 or greater sits at 35% for today and tomorrow, dropping to 30% on Sunday. The practical takeaway is this. If you work with HF radio, long line power grids, satellite operations, or precision GPS, the weekend is going to be interesting, but probably not catastrophic. If you live at northern latitudes and you want to photograph aurora, check the KP forecast Sunday afternoon and Sunday night. Here's the part that puts today's double X flare into its real context. Region 4419 didn't just fire those two X-class events in isolation, it fired them on top of an active swarm. In the 28 hours leading up to this morning's data pull, the same region produced 6 M-class flares. At 4:31 Universal Time yesterday, an M1.6. 10 minutes later at 4:41, an M1.2. 9 minutes after that, an M1.2. At 8:43, an M4.3. At 1:42 p.m. Universal Time, an M1.7, with an associated coronal mass ejection first spotted at 14:24 Universal Time, and at 5:02 p.m. Universal Time, an M4.9 with another CME, this one aimed northeast. That's 6 M-class flares in a single day, followed by 2 X-class flares in the next 7 hours. 8 major events from a single region. This is what a loaded sunspot group looks like when it's winding up. There are historical parallels. Region 9393 in March of 2001 produced multiple X-class flares in a similar window. Region 1, 0486, during the October to November 2003 Halloween storms produced 4 X-class flares in 6 days, including the X17 Plus event that remains one of the most powerful flares ever recorded. I'm not saying today's region 4419 is going to hit those levels. I'm saying the behavior pattern, extended M-class swarm transitioning into clustered X-class activity from a single beta-gamma-delta sunspot region, is the same pattern the Sun has used before to produce major space weather. The other thing worth noting about the preceding swarm is that the M1.7 and the M4.9 each launched their own coronal mass ejections. The M1.7 CME was first observed in coronagraph imagery at 24 past 2 p.m. Universal Time yesterday. The M4.9 CME was first observed in the GOES 19CCOR1 instrument at 15 past 6 p.m. Universal Time. Neither of those 2 CMEs is thought to have had a significant Earth-directed component on its own. They were both aimed off-axis. But their existence in the data stream matters because it tells us how productive region 4419 has been over the last 48 hours. Not just firing flares, but launching actual physical plasma into the inner heliosphere repeatedly. When a region produces this many CMEs in rapid succession, the interplanetary medium downstream gets cluttered. Solar wind density increases. Magnetic field complexity increases. And the next CME that arrives has to push through the exhaust of everything that came before. That's one of the preconditions for cannibalization, and it's part of why today's setup carries the upside risk it does. Here is the part of today's story that is genuinely strange. As of the Space Weather Prediction Center's data pull at 7 minutes past 1 Universal Time this afternoon, Earth's magnetic environment is completely calm. Solar wind speed at the SWPC feed is sitting at 383 kilometers per second, down from about 480 kilometers per second the day before. The total magnetic field BT is averaging around 4 nanotesla. The BZ component, the north-south orientation of the interplanetary magnetic field that matters most for coupling into Earth's magnetosphere, is flipping between plus and minus 4 nanotesla. Nothing dramatic. Observed KP over the last 24 hours has peaked at 2.67. The most recent 3-hour value was 1.33. On a scale that goes up to 9, we are sitting in the low 2s. That's not a quiet day. That's a very quiet day. The eruptions have already happened. The X-flares fired. The shockwave is already moving through the corona. The CMEs are already in the inner heliosphere. But the energy has not yet reached us. The weekend storm is already on its way. But right now, the Earth's magnetic field doesn't know. That quiet background matters. When a shockwave arriving at 1,293 kilometers per second slams into a magnetic field this calm, the contrast between the before state and the after state is going to be sharper than it would be in a noisy environment. It means the signature of the storm when it arrives will be cleaner and easier to measure. It also means that if the cannibalization scenario plays out, the amplification will stand out more clearly. Right now, at this moment, everything is still. That is the part nobody is talking about. Here's why today is not an isolated event. Region 4419, the region that fired both X-flares, is now at north 15 west 77 degrees, essentially at the sun's west limb. Within about 48 to 72 hours, it will rotate over the edge and out of Earth's view. Its ability to fire at us from this rotation is nearly done. The current probabilities SWPC is publishing for that region are 75% C-class, 40% M-class, and 15% X-class. Meaning a third major eruption before it goes over the limb is plausible, but that window is closing. Except the sun is not winding down. The sun is rotating. And what's rotating onto the Earth-facing side is bigger than what's rotating off. Region 4420 is at north 16 east 11 degrees. It is moving toward the central solar meridian from the east. Its area is 250 millionths of a solar hemisphere. Region 4419, the region that just fired twice, is at 220 millionths. Region 4420 is larger. It has 20 sunspots. 4419 has 7. Region 4420 also carries the same beta-gamma delta magnetic classification. And SWPC has specifically noted that the region has been growing and consolidating in its trailing and intermediate spots, with increased shearing observed in the intermediate areas. Shearing, in this context, is the magnetic equivalent of winding up a rubber band. Current flare probabilities for 4420 are 65% to C-class, 20% M-class, and 5% X-class. Those numbers will rise as the region approaches central meridian. And then there's the third region. Region 4.423 was not even numbered at the start of today. It was numbered during the current observation period after exhibiting rapid growth. It sits at south 5 east 30 degrees. It carries the beta-delta magnetic classification. It has 7 spots and an area of 40 millionths. And it has already fired its own M-class event, an M1.9 at 9:07 Universal Time this morning. So, to be clear about what the Sun looks like right now, 3 simultaneous regions carrying delta-class magnetic configurations. That classification, opposite magnetic polarities crowded within less than 2 degrees of a single penumbra, is the signature most strongly associated with X-class flare production in the observational literature. The Sun has 3 loaded chambers, one of them just fired twice, the other 2 are rotating into position. And while region 4.419 is about to go over the west limb, regions 4.420 and 4.423 are rotating toward the Earth-facing side. If either produces a major eruption over the next 4 to 11 days, the CMEs they launch will be directly geoeffective, not glancing, not off to the side, but straight down the Sun-Earth line. Today's event is not the ceiling of this sequence. Today's event is the opening act. Every time there's a major solar event, a recurring claim surfaces online that the flare was engineered or amplified by terrestrial electromagnetic facilities, most commonly the High-Frequency Active Auroral Research Program in Gacona, Alaska. Let me dispatch that quickly. HAARP's peak transmitted power is 3.6 megawatts. A single X 2.5 solar flare releases energy on the order of 10 to the 25th or 10 to the 26th joules. That's roughly 14 orders of magnitude more than HAARP's total annual output. No terrestrial facility can produce a solar flare. The physics doesn't work, the scale doesn't work, the energy budget doesn't work. The 77 expert survey published by Shearer, West, Caldera, and Davis in Environmental Research Letters in 2016 systematically documented the scientific consensus against large-scale covert atmospheric manipulation programs, and the same logic applies here. Moving on. Solar cycle 25 was supposed to be a mild cycle. The official NOAA prediction, published in 2019, projected a smooth sunspot number maximum of approximately 115 in mid to late 2024. That was the consensus forecast. It was the number on the official NOAA Space Weather Prediction Center page for years. That number got passed a long time ago. Observed smoothed sunspot numbers have exceeded that prediction since mid-2023. Monthly values above 150 have been routine. Peak monthly values have pushed above 200. Cycle 25 is among the stronger cycles of the space age. An alternative framework developed by Scott McIntosh, Robert Lehman, and collaborators at the National Center for Atmospheric Research argued back in 2020 that Cycle 25 would substantially exceed NOAA's consensus forecast. They called it the Terminator framework. It was controversial. It is now increasingly vindicated. And here's the part that matters for what just happened today. According to the consensus timeline, solar cycle 25 should already be in its declining phase. Peak activity was supposed to be behind us. The region count should be dropping. The flare rate should be falling. That is not what we are seeing. We are seeing 3 simultaneous beta-gamma-delta or beta-delta regions on the visible disk. We just saw 2 X-class flares from a single region inside 7 hours. We have a CME en route, a shockwave moving at 9/10 the 90th percentile, and 2 additional loaded regions rotating into geo-effective position. History has a specific lesson for this moment. The October to November 2003 Halloween storms, some of the most powerful space weather events ever recorded, including the X17 plus flare and multi-day G5 extreme geomagnetic conditions, arrived in the declining phase of solar cycle 23. The declining phase is when the biggest events of that cycle hit. Declining phase does not mean quieter. It means we're past the broad peak in sunspot count, but it says nothing about the probability of individual extreme events. Now, those can come at any point on the downslope. Today's configuration is consistent with a cycle that is not finished. And that is what makes region 4420's approach to central meridian over the next 7 to 10 days the thing to watch. It will tell us whether today's double X flare was this cycle's peak or just the opening move. Let me give you the forward-looking frame. The immediate window is Saturday afternoon, April 25th, into Sunday evening, April 26th. The Earth-directed component of today's first X-flare CME is expected to arrive late on Saturday into early Sunday. The second X-flare's CME is still being modeled. The glancing blow from yesterday's M1.2 CME is expected on Sunday. All 3 may merge. If they don't, we're looking at a minor to moderate geomagnetic storm. G1 conditions definitely, G2 possible. The expected peak KP is 4.67 during the 11 a.m. to 2 p.m. Eastern Time window on Sunday. If you're in the northern tier of the United States, North Dakota, Montana, Minnesota, Wisconsin, Michigan, northern New York, northern New England, that's an aurora window worth watching Sunday night. If cannibalization amplifies the event, aurora visibility pushes further south. On the ground, if you work with high-frequency radio, long-line power systems, or precision GPS, Saturday night through Sunday night is when to expect sporadic issues. Nothing catastrophic, no widespread blackouts, but a noisy window. The forward window is 4 to 11 days out. Region 4420 is the one to watch. It's larger than region 4419. It's more complex, it's growing, and it's rotating into Earth-facing position right now. Any major eruption from that region, while it's near the central solar meridian, would be directly geoeffective. Not glancing, not off-axis, but straight at us. And region 423, the newly numbered southern hemisphere region, has already shown it can produce M-class flares. Any continued growth, there is a second front. The things that would upgrade this story over the next week. Any X-class flare from region 4420 while it's Earth-facing, any sustained large area growth in region 4423, a surprise eruption from a new region not yet numbered, or any sign that the Saturday into Sunday arrival is running faster or hotter than SWPC's current forecast. There's also a broader data point to keep in mind. The greater than 2 mega-electron-volt electron flux at geosynchronous orbit peaked at 3,446 particle flux units yesterday evening at 25 past 4 p.m. Universal Time. That's elevated. It's been elevated for days, and transient flux suppressions are expected on Sunday as the glancing CME influences reach us. For satellite operators at geosynchronous orbit, that's the thing to watch. Not just the KP forecast, but the electron environment around their fleet. The greater than 10 mega-electron-volt proton flux, which drives the S-scale solar radiation storm warnings, is sitting at background right now. Today's peak was 0.39 particle flux units, well below any warning threshold. But SWPC's 25% probability of an S1 event over the next 48 hours means protons remain on the forecast board. If region 4419 fires another major flare before it rotates off the west limb, or if region 4420 erupts as it approaches central meridian, the proton environment could escalate. So, the recap. 2 X-class flares in 8 hours from the same sunspot region, a shockwave moving at 1,293 kilometers per second, above the 90th percentile of observed CMEs, a 10-centimeter radio burst at 570 solar flux units, 4.5 times daily background. An Earth-directed coronal mass ejection component arriving late Saturday into Sunday. A possible cannibalization setup with yesterday's M1.2 CME already en route, 3 Delta-class sunspot regions active on the Sun simultaneously. A cycle that has been overperforming its official forecast for more than 2 years, now in what was supposed to be its declining phase. This is not a Carrington event. It is not a Gannon-level storm. It's a minor to moderate geomagnetic event with upside risk and a loaded solar configuration behind it. We'll be tracking the CME arrival window as it develops, and we'll be watching region 4420 as it rotates toward Earth-facing position. This story is not over, it's barely begun. Stay with us and subscribe to the Space Desk so you don't miss any updates.